Cool. All right. Welcome, everybody. Um, so today, I have a few ideas for what we could talk about. Um, Really, two. So one is we can continue talking about the testing, like test infrastructure, how we do local testing, how CI/CD works. The other idea is I have an idea for medium-sized contribution, and we can go over like I can get started building that contribution to Athens and go through how to submit pull requests and all that good stuff. So what do people think? Testing or watch me fumble around with code for an hour and maybe give me some tips? Code, thumbs up, thumbs down, testing, thumbs up, thumbs down. Okay. Mark, Banner, all good with code. Okay. Ted, I put out two ideas for what we could do today. One was we can talk about testing in CI/CD, how we do it in Athens. The other one is I can go through and start with a contribution to Athens and show kind of the full scope of what it entails to write some code and then get it all pushed up to a pull request. Hi, Marwan. Thanks for coming out. Yeah, so Ted, what do you think? Code, thumbs up, testing, thumbs up, and welcome, by the way. Okay. All right, so we've got one for testing, we've got two for code. Let's spend the first half hour or so going through some testing stuff, and then let's do the second half hour is I'll go through starting a contribution to Athens. So maybe we'll do like let's do like 20 minutes for testing, and then we can have like 40 or so minutes, so a little bit longer for code. So I'm going to share my screen. Cool. Can anybody not see this? Can you put it in chat if you can't see it? I'll assume that we're good then. Okay. So last week we did mostly walkthrough of like local testing, how the local testing all works. And I focused a lot on the Docker-based tests. So this is the makefile. If anyone isn't familiar with makefiles, I went over it a little bit last week, but I'll just do like a brief 10-second thing. So makefiles are approximately quick ways to run a script by just typing make. So in this case, if I wanted to run the tests, all the unit tests inside of Docker containers, I would go in here and do make test-unit-docker. And that's going to end up running these two commands, and then these two commands are not related to makefiles, but they take care of a lot of things around setting up the unit tests and running the unit tests. So I went through the makefile focusing on the unit tests and the end-to-end tests inside of the Docker containers. And these are sort of representative of the setup that we use inside of our CI/CD system, and how CI/CD sets up the test environment and then runs the actual tests. So I also mentioned last week that we use drone CI to do our Linux-based tests and AppVeyor to do our Windows-based tests. So I'll show the websites for drone and AppVeyor in a second. But first, the configuration files, they're fairly similar. They're built with YAML both. And this is the drone one. So the drone one is kind of like a pipeline. So it's this YAML array called steps. And we go through a bunch of different steps. So step one, we do a go mod vendor here and a go mod download to basically download all of our dependencies for Athens and then put them in the vendor directory. Then we go through and we do our build. We make sure that our build succeeds, that our formatting, our vet tests, and our actual tests all succeed. And these tests do things like try out storage tests against GCS and Azure Blob Storage and Mongo and Minio. And we also do some tests around our distributed locking using Redis. Then we go down here, we do our Docker build for our, I believe this is, when we do a tag, so a GitHub release, this is when we do our Docker push. We also publish our Helm chart. And then down below, these are services. So this is sort of the environmental setup that we do so we can run our tests. So Ted, your question was, do the tests start up a previous version of Athens? And if we go up to the Go proxy var, this right here, I'm doing this from memory, and Marwan, you can maybe you can chime in here. I do believe we start up in Athens, but this Athens is pointed to GCS storage that already has all of our dependencies.
Can you actually, so it's an Athens, if you just look up Athens-proxy on the same file, you'll see it being run. There it is. So it's Canary, meaning like the latest version.
So this, in a way, this is kind of like its own end-to-end test.
Yeah, so this image here, it's the Canary, meaning like whatever we had just published or the last thing we had just published.
Yeah, and this one is interesting. Marwan, this was like a New York Times. This is kind of what you all do in your own CI or something like that.
I mean, drone has nothing to do with the New York Times, but yes, we use it. So I was pretty comfortable with it, and it's basically like it's very similar to Circle CI, but I found it to be a lot easier to work with.
Oh yeah. Sorry, I meant this strategy of like having a GCS.
Sorry. Yeah, for sure. I mean, basically, that's sort of what we do to before we deployed our own Athens throughout the company. So if you deploy your own Athens throughout the company, you can just use that URL you probably have like internally. But for now, if you don't do that, you can just do exactly this, which is basically run a background container of Athens that points to some storage. And that storage is never going to change. So even though Athens goes up and down on every build, the storage is persistent, which is kind of what we do here for testing, actually, not for building other applications.
That's kind of cool because then you don't have to, then you can just talk over localhost instead of having to reach out to an Athens somewhere on the internal network.
Yeah,
over the internet.
Exactly. Yeah. That was kind of the workaround we had for a while.
Yeah, that's rad. So Ted, also worth mentioning, at least I personally set my Go proxy environment variable to this. I just used the Go the upstream Go Teams proxy just because it's fast, and I don't want to rely personally on the experimental Athens that's running in the cloud because it's experimental. But yeah, I think you can choose pretty much anything in this drone setup, though. It's kind of cool. Yeah. So down here, these services, I think these are the services that our unit tests and our end-to-end tests rely on. So like I said before, Mongo and Minio are storage backends. So we have unit tests that test these storage backends. And then we also saw up here, we kind of gave away via these environment variables some of the other tests that are running for storage backends. So Google Cloud Storage and Azure Blob Storage. And eventually we're going to have to get in S3 storage as well. But in the meantime, we have tests against Minio. And Minio has an S3, vaguely S3 compatible API. So a lot of our S3 code gets exercised via those backend storage tests. And so we've got decent coverage on all of our storage tests. The unit tests also do file system backend as well. And then we also have tests for this thing called a stasher. And the stasher has a variety of different plugins, but Redis is one of them. So we are setting the Redis here, the environment variable to point to the Redis. And then down here, we are running the Redis right there.
If you want, I don't know how deep you want to go into this, but I've always thought the how to test a distributed lock was always kind of cool, and that we don't. So if you go into the stasher in the package folder on the left,
this thing.
Yeah, so there's with Azure, with GCP test, for example. If you scroll down, yeah, we basically just run sort of like, we basically run like two or like a bunch of randomly, like I guess the number is 5. We run 5 different commands to stash something, or 5 go routines to stash something with different results. But we only expect the first one to come back. Like even though the second stash came differently, the third stash came differently, the first one is the one that we expect the first one to be the correct one.
Gotcha.
Yeah, and or like we basically even like just error on the, what we can do is we just error on the second and the third. So if you like have 5 go routines, the first go routine doesn't error, but 4 go routines error out, none of them should error because we should all we are all like a single flight on the first one.
Oh, okay. So let's back up for 1 second. Has anybody heard of how this Athens stasher thing works? Has anybody not heard of it? Let's go there. Okay, cool. All right. So Marwan, can you explain the stasher in 2 sentences or something high level like that?
Yeah, the stasher is basically, we don't call it cache because cache entails that it might be deleted in the future, which is the opposite of what Athens is about, is that when we store something, we hope it never gets deleted. So stash is the operation of getting a module from VCS and storing it into the Athens storage. It's literally a get and a save. So it's 2 operations in one function. So the get from the VCS is using go mod download, which is abstracted as what we call a go get fetcher. And then once we get that zip info and mod content, we just copy paste it into the storage and the stash is done. The reason we want a distributed stash is that if we run 2 or different 3 go gets, we only want the first one to succeed. We don't want to override the storage. We want it to be immutable.
So we have this. So if we're running like 3 Athens servers as one sort of unit, we have this mechanism to make sure that only one of the Athens servers gets the code, right?
Yeah, so we only stash if let's say a module at a version is not in storage. So let's say a user asks Athens to get module A at version 1, and if that doesn't exist, then we run the stasher, because the stasher is what's able to get it from the internet, stores it in the storage, and says, I'm done. And then we actually just try again to get it from storage.
So this is kind of like a distributed lock sort of thing going on.
Yeah, so if four requests, say like four requests came in at the same time, and all these four requests thought there's nothing in storage, then all four requests will attempt a stash, and we don't want that. If four requests came in at the same time, we only want one of these four requests to attempt a stash, and the three other ones to just wait. So you can imagine in memory, that's easy. You could just have a mutex. But if you have different servers, then those four servers have to somehow know about each other.
So Mark asked, this is only the case if the requests are the same, i.e. same package and version.
Exactly.
Yeah. So maybe we can sort of pick apart this test, this particular line 40 to 51, to figure out what's going on. So we've got this error group, and we're doing 5 eg.go calls. Each one of these calls should return an error of some kind, nil, or hopefully not an actual error. And then our eg.wait call is going to return an error if any one of those .go functions returns an error themselves.
Right.
So
it might be, if you want to take a look at the mock, if you just go to def on mock gcps stasher, you look at the stash function here. So it just calls storage save, and it returns the error that's coming from under the storage itself. And
okay.
So if you go back to this test itself, yes, so the way this GCS thing works is that if you look at the content, we're adding new content every time. The GCS lock, what we can do is that we can actually say, Google Cloud Storage has the feature of saying you can save a new module or you can override a new module, but if the content is different, we're not going to let you do it. So the fact that we have 5 every time for every Go routine, we're calling content equals uuid.new.string gives us a new content. And so we're trusting GCS to say basically that if the content changed, we're not going to be able to save anything. And that's what with GCS lock does. You might want to click on with GCS lock. There is in the stash process, yeah, if you look at the stash or dash, it's actually, yeah, so that's the error that it returns. The kind already exists, meaning that if GCS returned kind already exists, meaning like we're unable to stash this because it's already there, we're actually not going to return an error. We're going to return that version itself and saying it's actually done.
So this is saying there's going to be 5 Go routines that all race to write something, but the 4 that are not the first one are going to get this kind already exists error back.
Exactly.
That's basically a no-op then.
Yeah, and then we say, well, then the version is correct and it exists, so that's all we need to know.
Cool. Oops. So if we go back here, then the first one of these Go routines that gets run stores the thing and then returns back nil. And then the next 4 are all going to just get a kind already exists error, and they're going to return back nil as the error as well.
Right. And then we want to make sure that if we call storage.info, then we actually do get what we're supposed to get. One way I see this, I mean, there's no way to know which of the 5 Go routines is actually going to be the first one to succeed. And that's totally okay because those are concurrent. But if we can potentially like save the first one and be aware of what the content is of the first one, we could potentially enhance this test and say, send 5 Go routines, but maybe the first one is a little bit quicker. And then on the way back, when we check the info, we know that it's only the first one that got saved, not the other four. But
Sounds like maybe that could be a good PR, maybe a good first PR someone might want to work with.
for sure.
And Mark, what exactly do you mean by multiple fetch requests?
So, for example, if multiple people hit the Athens server doing a fetch of a certain module, when it hits, the Athens then hits the real endpoint to fetch it from, will that hit it multiple times, or will it go? Oh, I'm in the process of fetching this. Hang on while I get the original content back.
Yeah, that's a very good point, actually. I believe we do try to get everything. So the problem is there's a couple of issues. One is sometimes you ask for a pseudo version or a dynamic version. So a dynamic version saying, give me the master. And the master changes over time. So we're not going to be able to say, oh, there maybe within a few seconds, maybe we don't care, even if like say someone pushes the master twice in a row, we'll take the first one and ignore the newer one. But that's one thing to kind of account for. The other part is exactly what you said, could be a really good enhancement, which is we only download from the internet and then save to the storage, and only once we save the storage it says this already exists. It could be an enhancement where instead of downloading from the internet, we already figure that out. I think that's what you're suggesting, Mark, right?
Yeah, basically, yeah. So, excuse me. If for whatever reason multiple people just so happen to ask for the same thing at the same time, which isn't yet cached, it'll only go to the internet once to fetch it.
Yeah. So this kind of depends on the implementation of a stasher. And so if you look all on the list, you see with GCS, with Redis, with single flight. With single flight is the in-memory. So the in-memory one, that's exactly what it does. But in-memory assumes you have a single instance, of course. The GCS one is kind of the easiest thing because it kind of gives you that feature, so we didn't have to implement anything extra. With Redis, I believe it's the same way. We don't download anything from the internet. We first lock and based on the module and version. And we have also an etcd cluster that you can set up. And this one as well, we don't download anything from the internet until we just trust the first one that acquired the lock is the one that's actually going to download something from the internet. So I believe GCS is the one that's kind of an anomaly where we download and store, and only when we try to store a second time, it will tell us it already exists.
Yeah. It looks like the Azure one also has this acquire lease thing going on.
So yeah, this one might be also more efficient.
Yeah. So they have a locking, like an actual locking mechanism.
That'd
be interesting to see if we can do that with GCS somehow.
For sure, yeah. I feel like we will be able to. It's been a while. I don't remember how or why. I think that was just like it made the GCS stasher kind of be really stupid and simple. A lot of the times, again, maybe GCS is not the best if you're setting up a public proxy, but for an internal proxy, you're probably not going to get a lot of concurrent requests of the same module of the same version all happening at the same time while the storage is empty. It's kind of like a lot less likely. But it could make, if you're making a public proxy using Athens, the other options might be a lot more scalable. So if you just configure it to use an etcd cluster or a Redis cluster or even Azure, those might be actually more efficient.
So Ted, you said something about Dynamo and S3 together. Would that be doing like the whole distributed lease thing and solving this problem that way? That'd be pretty cool. If you're up for...
Yeah. So I just did a little bit of digging, actually. It looks like Amazon has something called object lock. I mean, I personally cannot actually test or use that right now based on my own, internal restrictions. But it looks like it's pretty easy to set up. Might be worth looking into. I'm not sure. But the overall the mocking stuff seems like it would be pretty simple to accomplish. I was just looking at the interfaces and that kind of stuff, and yeah, it would either be a good first PR or a good uh, project for somebody to work on and implement across the different tests, because it looks like, again, it would be useful.
Nice. Would you mind opening an issue for that, Ted?
Yeah, I can do that.
Be awesome. Thank you. Cool. So let's go back into here. So we kind of dove into the stasher. Let's check out just another stasher. Let's check out Redis, because this one does a lock and it's fairly simple. So we've got basically, we format the module and the version together into basically just a string. So it looks like that. It's module at version. We get a lock based on the Redis key that is called the same thing as the module version. And then basically once we have that lock, then we can do all of the things. This is basically the critical section where either all of this will happen while you have the lock, or you'll wait until someone else is done with it. And this is kind of just, I believe this is all done. Yeah, this is all built into the Go Redis client. So basically it's all the distributed locking and that complicated locking stuff when you're in a distributed setting is all done, which is amazing because we don't have to test it. And then at that point, we can just go and do the exist check and the stash check, or the stash process, which is, like Marwan said, download and store in storage. We can do those things together and just assume either they'll all be done or none of them will be done. So this code ends up looking pretty simple, and the etcd code is similar. If we go over here, we have sort of the same idea where we create the string that represents a unique module at version. We get a new mutex. We call lock on the mutex right here. And then we go down and we've got this familiar code where we check to see if the module exists. And if it does exist, then we're done. And if it doesn't exist, then we can go and do the stash, which again is just to go get it from upstream, VCS, or another module proxy, and then store it in storage and then just return because we're done. So these are kind of nice little wrappers around, essentially around a storage that allow you to run a bunch of Athens, like Marwan said, in sort of in production. If you've got a lot of people asking for brand new modules that Athens doesn't have in its storage.
One thing that I think is pretty neat in that setup, if you scroll down, actually one thing that might be worth mentioning, and I don't want to get out of the testing topic too much, if you look at the function signature of the stash function, is that it takes a module in a version and it returns a new version, which might be weird to some people if you're not familiar with Go and versioning, especially in VCS. Was that like I tell you, hey, can you give me module A at version 1? And it says, well, okay, here's module A at version 3. And you're like, what? And the reason for that is because a lot of versions are dynamic. So it's never going to be version 1.2. It's going to say, no, it's 1.3. When it comes to Semver, it usually keeps it the way it is. But you can say version master, and you can literally have the word master, or you can put a whole GitHub SHA. So you say, can you give me, like for the stasher itself, you can say, can you give me module A at version entire SHA commit? That's like 32 characters or whatever. So then what it will return, it'll say like, okay, here's version 1.2.3 timestamp dash on the little SHA, the 12 characters of a SHA. And so that's what gomod download gives us. And this way, when you ask for master, the stasher will never find it to be found, because we never store a version as master in our storage. Because imagine if today you stored a version called master, and then master is going to be stuck. No matter how many times you push to master, you're always going to get that first version, which is not a wanted behavior. And therefore, whenever we say, does this thing exist? If you pass us master, the answer is always going to be no. And we're always going to end up fetching a new version.
So we kind of get that immutability aspect because we never overwrite anything in storage, right?
For sure.
Nice.
And on that note, I have to run.
Okay. Thanks for all the explanation, Marwan. That was awesome.
No problem. Peace out.
See ya. So, yeah, we ended up on stashers, and this is some of the most complicated code in Athens, just kind of because you have to know like this context, a couple different pieces of context. You know, how versioning works with Go modules, how storage works in Athens, plus how these backends do concurrency. So how etcd does concurrency, how the Azure blocks work, how the GCS content checks work, Redis, whatever else. So it's like the intersection of all these different concepts and systems. So if anyone wants to do some work in this area, like adding a new stasher or anything else, don't be afraid to ask. We've got Marwan did a ton of work in this space. He's always around. I can help as well. Most of what I'll be doing is bumbling around with you, doing some screen shares and figuring out what's going on. And that's totally cool. We can do that anytime. So one last thing in the stasher space that I'll point out is that we've got, Marwan mentioned this too, we have an in-memory stasher called single flight. And single flight, if we go to the stash, this is the stash function. This is basically a bunch of Go routines in memory using a mutex, just a standard Go mutex, to make sure that only the first one gets to do real work, and the other ones just, when they get unlocked, they just see the work's already been done. So I'm just going to take what's been done already out of storage and return it. And so this is not only like, this is a good example of basic concurrency stuff in Go, but at least I think it's a good example of concurrency stuff in Go. But if you're looking to do some stuff in the stasher package, this would be a really good place to start, because it doesn't deal with any of these external etcd-like systems. It's really just in memory. So something to keep in mind. So with that, oh, thanks, Ted. We'll talk to you soon. Thank you for making the issue too. So with that, we got off topic from testing, but that's totally okay. I can switch over to writing code, or we can continue on down this path or testing or whatever. So who's thumbs up for code? Who's thumbs up for testing? Okay, I'm just going to choose. Let's go do some coding. I am actually going to go and pick up an issue. And there is one issue that I have kind of been toying with. I've kind of wanted to see Athens have a webhook that allows you to tell it to asynchronously download one or more modules, just kind of in the background. And this would be useful if like you just joined a new team. The new team has a code base that has like 1,000 module dependencies, and he basically wanted to spin up in Athens and run a single curl command against it, and basically have it just start doing work behind the scenes to warm up the storage so that your team can come in basically like tomorrow morning and start doing builds against that Athens and not have to worry about the Athens going and doing all these stash operations. So it's a nice optimization. It might be an unnecessary optimization, but I want to go kind of prototype it and see, A, what does it look like in the code? And B, is this thing going to actually be valuable for someone? I can see it maybe being valuable for a publicly hosted Athens, which might be a thing in the future. And that one I'm almost sure would be valuable, but we'll see if it would be valuable for privately hosted Athens. So first thing I'm going to do, I'm going to do a git fetch. And by the way, I've got a bunch of git commands. So I'm going to do a git fetch -- all. This is going to fetch everything from my upstreams. And GCO is git checkout. So I'm going to create a new branch, and I'm just going to call it proactive webhook. I'm going to branch off of upstream, and basically that's it. And it looks like my go sum is modified for some reason. I'm just going to ignore that for now. That's fine for now, and we'll get it fixed up later. So now code. We have like 20 minutes, so I'm going to start kind of from the top and just going to build out the endpoint first, and then we'll go down all the way down to the stasher and storage. Basically, as we touch each different system of Athens. So I'm going to close all of my tabs because they drive me crazy. And we are going to head up to our CMD directory, and then under proxy, starting literally from the very, very, very top. This is our main. There's two things I'm going to pay attention to in main. We've got our config file where we do our config.load, and then we call this actions.app function. I'm going to dive into the app function first. So if we go over here, the basic skeleton of app is that we get the storage driver here, and then we go all the way down here. We do a lot of stuff that's important, but it's not the core of Athens. We go all the way down, and we then call this add proxy routes function. So add proxy routes literally registers the module download API, the routes for Athens module download API. So if we go into here, these are like some sort of ancillary things, but heading down here, you can see there's this big comment called download protocol. And the download protocol is sort of buried underneath here, download.register handlers. So we've got our latest here, our version, the .mod endpoint, and then the .zip endpoint. So now they're unraveling. You can see that regex for a module, and then /@v, and then the zip file, .mod file, .info file, and then the latest endpoint. But I'm not going to go this deep. I'm actually not even going to go this deep, because really I'm not trying to add a proxy route. I'm trying to add a different route. So it might make sense to add it under here, but I'm not going to quite go that far. I want to be special, and I'm going to create a webhook file. I'll call it webhooks. So I'm going to copy basically this function, and I'm just going to call it add webhooks. So, and by the way, this is totally all off the top of my head. I have no idea what I'm doing. So if someone sees me doing something stupid, please feel free to put it in chat or just speak up. Totally open to doing something a better way. So I'm going to leave these function parameters for now. Not sure what I'm going to need yet. So this is kind of where I need to decide what my data structure is going to be. So like how am I going to pass in and how am I going to accept all of the modules and all the versions that I want Athens to go and fetch behind the scenes. So I'm just going to do like a little bit of just experimentation. So let's say I'll just call this webhooks post body. And let's say the post body is going to be a dictionary with one key. So I'm going to call it modules to fetch. And then I'm just going to have a slice. But in JSON, it would be a list of these things called modules. And let's call this a webhook module. And then we're going to do this. I would prefer to have each webhook module to have the module name and then a slice of versions so that Athens can go and grab, it can iterate through this modules to fetch. And it can know that every single element in the slice is going to be the only element that has that module name. It might have a bunch of versions, but there's going to be no other element in this modules to fetch slice that is going to end up having the same module name. So we're going to do module name. And then we're going to do module versions. That's going to be our slice. And let's see, I might be able to just put these all inside of the function. And then we are going to do a r dot, how do we do this again? Handle func. Just top of my head, I'm going to call webhooks bulk. And then we're going to just call our function bulk async webhook handler. No idea if that's the right thing, but I'm guessing we're going to probably want to pass our storage backend and probably our logger in there. And then we're going to call, we're going to make this only be a post. We need the HTTP method, obviously, to be something that can have an HTTP body in it. So off the top of my head, the choices that I have are post and put. So I'm just going to choose post. I doubt this is valid REST, but that's what I'm going to go with for now, and probably come up with something better later, right? That's kind of the point of the PR. So I think I had to move that up so that this would work out. And basically now, this is like the high-level skeleton. This would be like if you built a house and you just had the framing, I guess. No electric, no plumbing, no anything. So I'm going to go dive in then with this thing, bulk async webhook handler. And again, this is probably going to even go in a different package, but I'll cross that bridge when I come to it. So this has to return a func. So I'm going to go into handle func. So basically, the handle func that I call has to take in the standard HTTP handler func, this thing that I have highlighted. But bulk async webhook handler, I need to pass it the logger and the storage. So I need this to return the func. So it's a func returning a func. But the key thing is that this function signature that it's going to return matches up with this thing, because that's what handle func requires. So we got that going on. I'm going to add the types in for L and S. So S is the storage backend, and L is the logger. It's a pointer to the logger. All right. So now, again, I'm going to just keep doing my skeleton thing. It's kind of like I keep putting off actually doing the work. But as you'll see, like we've got 13 minutes, so I don't know how deep into this I'll actually get. So now we've got our func. Basically now we need to start doing some stuff with the storage, and probably with the stasher. So this is when things are going to get a little hairy for me, because I'm going off of memory on how these storages work. So I'm actually going to ignore the stasher for now. And basically I'm just going to go and do a storage.get. So for those who aren't familiar, the storage.backend, which we've taken in here, this thing, why isn't that clickable? I don't know. But this thing has basically an interface that is the composition of a bunch of other interfaces. So, oh man, can't click on any of these anymore. My language server's broken. Oh, anyway, my task is to start getting a bunch of modules from upstream if I don't have them in storage already. And then once I've gotten them, saving them. So it's pretty much the same deal as what the stasher does. But the first thing that I really want to do is basically figure out, does the module exist? So I need to actually loop through each of the versions of that module. So first thing I'm going to do, I'm actually going to move these types down into my bulk async webhook handler. And I am going to decode, I'm going to JSON decode the body of the request into my struct. So my request is, I'm just going to say webhook module. And if you've done JSON work with Go, you might recognize this. If not, it's fairly simple. So I'm going to do if error equals JSON on Marshall, and I'm going to do a r.body, and I'm going to do a rec. I'll put it to do there, return error to HTTP client. And this on Marshall, oh, this requires a bytes. I think there's a way, there's a different JSON function. Does anybody remember if there's a way to decode directly from an io.reader? Maybe. I'm going to go check it out. So what I would really love is to be able to do something like this. JSON do stuff, I have no idea. And then I'm going to do r.body. Because then I can kind of skip the step of trying to decode all of this, trying to read all of these read closer bytes into some variable, and then going and passing those bytes to JSON on Marshall. It would be really nice if I could just make, if I could find a function in the JSON package that does all of that for me. So I'm going to see what we can do. Decoder, there, decoder takes an io.reader. So let's try this. And that's going to be r.body. And then let's see, what can the decoder do? It can decode into an interface. That's probably going to be the struct. Again, all guesses, but we're going to see what's going to happen here. And this is my pseudocode. I can get rid of that. And also, I'm going to defer closing that body till the end of the request handler. Just something that I remember that I always do that's important. So now by the time I get to here, to right here, now I've got my rec. The rec has modules to fetch. I can now loop through each module to fetch and then do a get on each individual module for each of those versions. I also noticed something. This is the wrong type. It should be this, because this is the top level thing. So now I'm going to skeleton out that loop. So now I've got my modules to fetch. So each one of these module to fetch things is going to end up being a webhook module. So that's going to have my module name and then each of the module versions. So I'm going to do another loop in here. Do a get fetch store using a stasher maybe for module to fetch dot module name and module version. And I'm just gonna put a little different notation in here. So that is that, and I'm actually gonna leave it there. So I can go and start doing my pull request submission thingy. So what did I do wrong here? Return func. Oh, that's what's wrong. There we go. And I'm going to just do this so it doesn't bother me about the unused module version variable. And yeah, so we've got 6 minutes. Let's go submit a PR for this. So the basics of what I'm going to do, I'm going to obviously commit this code. I'm going to push up to my new branch. Then I'm going to use a CLI tool that I use called Hub, H-U-B. Hub is going to create the new pull request for me. And then I'm going to actually I'm going to do it differently. I'm going to create the pull request on github.com. And I'm going to create a draft pull request because I'm not really ready for this to be reviewed. Obviously, I haven't really done any of the meat of this. I haven't done the actual get and storage operations which are in it to do. So first things first, I love the GitHub desktop tool. I'm not sure what this is about. I'll have to figure that out some other time. The webhooks file, I actually forgot to do one thing. I forgot to call add webhooks. So I'm going to do that here. And add webhooks takes in router, storage, logger, and config, just like proxy routes does. And I have no idea if I need to create a new sub router or anything like that. So I'm going to create a couple to-dos here. Probably create a new sub router similar to proxy router. Proxy router. The other thing is put this behind a config flag so that someone can turn it off if they don't want webhooks, or on. So now I'm going to do that commit. Adding skeleton, I'm just going to call this adding skeleton webhooks. This is related to which PR? This PR. And then I'm just going to say fixes that PR, because that's my plan, is if I can get this thing merged, I would want that PR to be closed. So I'm going to commit that. And then I'm going to push this to an upstream. So I always push up to my origin on a new branch. I don't like to track pull requests against upstream to my master on my fork. Mark, I did not commit the modified go sum. I don't remember where that came from. I think it probably was from, I probably built Athens, and that caused the Go tool to update the go.sum with new versions and new SHAs. So I'll have to figure out what that is offline, but yeah, I'm not going to push it right now because I just don't know what's going on with it. So going back here, I always like to create a new branch on my fork, and then I submit a pull request from my forks branch up to master on github.com/gomods/Athens. That's what I call upstream. So let's do that. And normally I would use this tool called Hub. So you can run Hub pull request. But I don't know if it has a way to submit draft pull requests. So instead, I'm going to go to this URL that they give you in the output of git push. And I'm going to submit the draft pull request this way. So the way that you do it is you click this little arrow, you do a draft pull request, and I want to fill out the pull request template. So the problem I'm trying to address, this isn't really a problem, but it would be nice to have a way to tell Athens to bulk fetch a bunch of modules all at once. That functionality would be nice to warm up in Athens before end users start using it. I added a relatively simple webhook to allow this. And then my fixes, I'm just going to do fixes PR number 1341. And I'm just going to quickly make sure it's got the commits that I want. Looks pretty good, and submit my draft. So no idea what's going to happen with this. The only thing I know is that there's going to be a ton of changes that I need to do to make this thing ready for master. Most of that is like actually figuring out how to implement the core storage part of this. But basically when I'm done, I would click ready for review. I would get people to review this. And generally, us, the maintainers, we stay fairly up to date on pull requests, on most of the new pull requests at least. And if I didn't get people to review this as fast as I would like, and same goes for you, if you have a pull request and you don't get someone to review it as fast as you would like, please chime in on the Athens channel, and we will get to it as soon as we can. So with that, just to be mindful of time, I am a minute over. So we did pretty good today. I feel like we covered a lot, which I'm happy about. So we're going to do it same time, same place next week. Think about if there's something you want to go over, you want to talk about. Either tell me or just bring it up next week when we meet, and we can talk about that. Otherwise, we can continue doing this. We can continue talking about stashers or testing. The sky's the limit. There's a lot of content to cover in the world of the Athens code base. So I'll tweet about it next week to remind everyone to come. I will put this recording up on YouTube today. And otherwise, I hope you all have a great rest of the week. See you all soon. You're welcome, Mark. Take care.